Assalamu alaikum. Welcome to chemistry for class 9th lesson for week 6 starting from 11th May to 15th May 2020. Hope everybody is fine and are enjoying a healthy Ramadan. All right. We will continue in this week with chapter number 5 and we'll talk about liquid state and the typical properties of liquid state in this lesson. The subtopics included for this week are evaporation, vapor pressure, effect of temperature on vapor pressure, boiling point, effect of external pressure on boiling point, determination of boiling point, and distillation process. Objectives of lesson for week 6 are: by the end of the lesson, students should be able to define the term evaporation, explain the process of evaporation and justify it is a cooling process, enlist the factors that affect the rate of evaporation, define the term vapor pressure, explain the process of vapor pressure and the factors that affect the rate of vapor pressure, describe the effect of temperature on vapor pressure, define and explain the term boiling point, explain the effect of external pressure on boiling point, differentiate between boiling and evaporation, determine boiling point of an organic compound, and the last but not the least is define the term distillation and explain the process of distillation. Here is the weekly distribution of the subtopics. I have also added some additional resources links. You may also find them in the resource section as well. The assigned tasks are respectively listed in front of each subtopic for you people to follow accordingly. All right, let's come to 5.3.1 evaporation. Evaporation is a phenomena in which the conversion of liquid changes to gas or vapors. And this phenomena occurs at all temperatures. This is called as evaporation. The diagrams illustrated as A, B, C. C on the left side is shown. You can see that the molecules in A, they are converting into vapor state. Molecules undergoing vaporization, and this takes place as the high energy molecules of a liquid, kinetic energy increases, and the high energy molecules, they able to escape from the surface of the liquid. They get enough kinetic energy that helps them to get rid of the intermolecular forces, keeping them within the liquid. So they as a result, the high energy molecules of that liquid, they get escape from the surface and they are collected at the top of the surface of the liquid as vapors, as you can see in B. So many vapors, orange color vapors have been collected at the top of the liquid. With the passage of the time, if you keep on heating, if you keep on heating the liquid, the number of the molecules that have been converted to vapors increases. So it means that if you increase temperature, rate of evaporation also increases. As you can see in C, that enough vapors have been collected. Now there, at the same time, some of the molecules as time passes, when they escape out of the surface of the liquid due to their high energy, as they cool down, some of the molecules they start converting back to the liquid state. That is called as condensation. You can see green color. The green color molecules, they are condensing back to the liquid state. So it means evaporation and condensation are the two physical processes that are going side by side. Evaporation is the conversion of the molecules of high kinetic energy from the surface of the liquid to gaseous states, whereas as soon as those high kinetic energy molecules they cool down with the passage of time, or with the lowering of the temperature, they start condensing or converting back to the liquid state. That process is called as condensation. All right. Here is another illustration in front of you. You can see that once again the evaporation is taking place, the conversion of molecules taking place from liquid to gas, and this is all because of getting high kinetic energy. The high kinetic energy increases. As the kinetic energy increases, the molecules they jump into gaseous phase, and the gases can be identified. They have large intermolecular spaces between them, but as soon as when the temperature or the kinetic energy decreases again, these water vapors can once again condense back to the liquid state. So it is actually the change of phase from liquid to gas phase, and as the temperature increases, the rate of evaporation increases. So it means that there is a direct relationship between temperature and evaporation. If the temperature increases, the kinetic energy increases, and if kinetic energy of the molecules increases, they can escape from the surface of the liquid, and as a result they can exist as vapors. And as soon as the kinetic energy decreases, they can condense back to liquid state as well. Alright, let's talk about the factors which are affecting the rate of evaporation. The rate of evaporation of a liquid can be increased by increasing the temperature of the liquid. This increases the kinetic energy of the molecules. Basically, the reason behind is the gain of kinetic energy of the molecules, and as a result that helps the molecules to escape the surface. Similarly, we have another factor, the surface area. If we keep, we might have observed that if we keep a liquid in an open container, like in a saucer, the molecules will escape more easily as compared to if we keep a liquid in a closed container or in a narrow bottle. If you are keeping some liquid in a narrow bottle, that helps and that decreases the surface area, and as a result the molecules they escape slowly. So evaporation increases with increased surface area. That's why you people spread your clothes on sunny day, because that helps to increase the surface area of the clothes, and as a result the water evaporates and dry, and these clothes are dry more quickly as compared to if you keep them lying together at one place. That will not help them to dry. So this is the process, that if the surface is open, the surface area is more, the molecules can escape easily, and the rate of evaporation is high. All right, this is all about the factors which are affecting the rate of evaporation. Evaporation results in cooling. One of the major reasoning questions are asked from it, how evaporation, or is evaporation a cooling process? Yes, evaporation is a cooling process. The reason behind is that as a result of evaporation, the molecules of high kinetic energy, they get rid out of the surface of the liquid, and as a result high energy molecules they are lost, medium energy molecules they are turned back into water, whereas low energy molecules they are left behind in the surface. As a result, the low energy molecules which are left behind, that results in cooling process. So the only reason behind is that the high energy molecules from the surface of the liquid they are lost, leaving behind the lower energy molecules. As a result, the temperature of the liquid decreases. This is the reason, since the temperature of the liquid is indicated by kinetic energy of the molecules, this escaping of molecules with high kinetic energy results in overall cooling of the liquid, as the molecules with high kinetic energy have been lost, leaving behind the lower kinetic energy molecules, resulting in cooling process. So the high energy molecules lost, lower energy molecules leaving behind, and resulting in cooling process of the liquid, or the end result is the decrease in temperature. All right, the next 5.3.2 is about vapor pressure. Vapor pressure, as previously we discussed that the let me show you with an illustration, that if the liquid is present in a container, the evaporation is taking place at all temperatures. As a result of this evaporation, vapors are collected, and when these vapors, of course, they start exerting pressure on the surface of the liquid. These vapors start exerting pressures on the surface of the liquid, and as a result the pressure exerted by these vapors is said to be the vapor pressure. So let's come to the definition. Vapor pressure: the pressure exerted by a vapor of a liquid with its liquid state in equilibrium with its liquid state. In equilibrium means that both the states are present. Vapor state is also present, liquid state is also present. So the pressure which is exerted by these vapors exactly on the surface where they have been collected, this is called as vapor pressure. Liquid molecules at the surface escape into the gas phase. These gas particles create pressure above the liquid in a closed container. So you can see from this illustration as well, see in these two flasks it has been shown to you that few molecules they are escaping first in flask A, for example, say it A, and this is flask B. In A you can see that the number of molecules they are escaping from the liquid state to gaseous state, but in B you can see a large number of molecules have been gathered on the surface and they start exerting pressure on the surface. This happens, so it means that if the vapors are large in number, the number of vapors increases, the vapor pressure increases. And if we have to relate it with evaporation, it means if the rate of evaporation increases, the vapors, the number of molecules of vapors increases, and if number of vapors increases, the vapor pressure increases. So far we have started now discussing or relating evaporation with the vapors and the vapors with the vapor pressure. All of them are directly related. The more the rate of evaporation, the more vapors are there, and if more vapors are there, more vapor pressure is exerted. See, this is an illustration which we have just talked about. Water is a volatile, it evaporates at all temperatures. However, the rate of evaporation is different at different temperatures. If the temperature is high, more evaporation is there, and if more evaporation is there, more vapors are there, and if more vapors are there, there is going to be more vapor pressure. See that the more vapor evaporation occurs, the more gaseous water is there. This is the rate of evaporation is increases. These evaporated molecules push against their surroundings. They start exerting pressure. See, the more the molecules are there, they start putting up pressure on the walls of the container as well as on the surface of the liquid. So it means that more the evaporation, higher the vapor pressure. More evaporation means that the rate is fast, and as a result large number of molecules are now existing as vapors. If large molecules are existing as vapors, it means they are putting up a large pressure or increasing pressure is there, so there is higher vapor pressure. But the water molecules can also go back, and a closed system will reach on equilibrium. As we already discussed, that the vapors are being formed, and at the same time the vapors are converting back to the liquid state as well. So there is a sort of equilibrium that established, and this between evaporation and condensation, at that equilibrium this vapor pressure exerted is called as vapor pressure. Effect of temperature on vapor pressure. There is a direct relationship between temperature and vapor pressure. The reason behind is that there is a direct relationship between temperature increases, evaporation increases, and if evaporation increases, vapors increases, and if vapors increases, vapor pressure increases. The more the temperature is high, the more kinetic energy is gained by the molecules, and the more kinetic energy is gained, they can leave the surface of the liquid easily, and more molecules are converted into vapors. And if large number of molecules have been converted to vapors, they can exert a greater pressure, and as a result vapor pressure increases. So there is a direct relationship between vapor pressure and temperature. Nature of liquid. The second factor which affects the vapor pressure is the nature of liquid. As we know that we have two types of compounds, polar covalent compounds and non-polar covalent compounds. Polar covalent compounds have strong intermolecular forces. These strong intermolecular forces hold the molecules together, thus making it difficult for these molecules to escape the surface of the liquid. So they have a lower vapor pressure. By this we mean that if a compound is polar, strong intermolecular forces are there between their molecules, so it becomes difficult for a polar compound to escape. Like water. Water is a polar molecule, polar covalent compound, and strong intermolecular forces, hydrogen bonds are there. So see that with the increase in temperature and vapor pressure, it has very less vapor pressure even at 60, even at 80 degrees Celsius C, and the vapor pressure is increasing slowly and for water. Whereas if on the other hand we see for ethyl alcohol and diethyl, which are non-polar means they have weak intermolecular forces, the molecules can easily escape. See at 20 degree, see the curve for diethyl ether, look at the rise in the vapor pressure. For diethyl ether, it is non-polar, molecules can easily escape, and as a result they can form more or large number of vapors at even lower temperatures, 20 degree, simply before 40 it starts boiling. Whereas if we see ethyl alcohol, it is slightly more polar as compared to diethyl ether. So see the curve, let me illustrate you the curve for this is blue color. I am indicating blue color curve for ethyl alcohol. See at 40 degree the vapors are still less than diethyl ether, 60. And lastly, if we compare with water, Water, see that it has very less vapor pressure as compared to ethyl alcohol and diethyl ether, and this is all because of increased hydrogen bonding or intermolecular forces that helps the molecules of water difficult for the water molecules to escape from the surface of the liquid. So this is how it means more polar a compound is, less vapor pressure is exerted by it at high temperatures even. Similarly, if the compound is less polar or non-polar, more vapor pressure, because more vapors it can easily form and more vapor pressure is exerted. All right, let's talk about converting vapor pressures. Vapor pressures can be measured in different units, and these units are mmHg, torr, atm. These are the some relationships in front of you, given to you. So whenever you are going to convert them, you need to follow these relations. See, if we have to convert mmHg to torr, it is easy, it is simply equal. Whereas if we have to convert from atm to mmHg, we will need to multiply with the factor 760, because the difference between 1 atm and mmHg is for 760 units. Similarly, if we need to convert atm to kilopascals, we need to multiply it with 101.325 kPa. So the difference unit is 101.325, and mmHg and kPa is related with 760 mmHg is equals to 101.3. So you need to remember the relationships. It will be easy for you to follow the conversions then. So two questions are given in front of you, people to solve them. See, it is the first is 727 mmHg needs to be converted to kPa. So we will use the third relation. We will use the third relationship, that is 760 mmHg is equals to 101.325 kPa. 1 mmHg is equals to, so you will find 1 is equals to 101 divided by 760, unitary method, and the given 727 will be equals to multiply with 101.325 divided by 760. So unitary method you will use, that the third relationship is there, 760 mmHg is equals to 101.325. 1 mmHg is equals to 101.325 divided by 760. And the third step is 727 mmHg is equals to 101.325 divided by 760 into 727. So this will give you the answer for kPa. Similarly, for the third, for the second one, 52.5 kPa to atm, you will use this relationship, this third one, kPa to atm, but this time you will be opposite relationship will be there. 101.325 kPa is equals to 1 atm. So 1 kPa is equals to 101.325 divided by 152.5. You can multiply it and you can calculate the answer respectively.